Hello and welcome to Algebra 1, Chapter 9.3, and today we are going to discuss our fourth way of solving a quadratic, and that is from a method called completing the square. So if you're keeping a list someplace of the 5 ways to solve a quadratic, this is number 4. We need to jump back to Chapter 8 real quick, and at the very end of Chapter 8, we used what was called the square root property. And so a little bit of refresher, if you have one factor squared like this, what we did is we took the square root of both sides and that canceled with the square, leaving us with an x minus 3 equals. And there are 2 square roots of 9, and so we had to add a plus or minus to our 3, okay, right, because 3 squared is 9 and negative 3 squared is 9. So we had both of those that we had to deal with. And to get x by itself, we added 3 to both sides. And we wrote this with this 3 first. This was 3 plus or minus 3. And then if this was math you could actually do, we did it. And so we did 3 plus 3 and got 6, and 3 minus 3 and got 0. And that was the square root property. And it works so nicely if you have this situation. So our directions here say solve by taking the square root of each side. You cannot do that. There's no way, there's nothing you can do with that. There's no property that breaks that down or anything like that. So before I can take the square root of each side, the question then becomes, well, can I rewrite this? So can I factor this? Or is this a perfect square trinomial? So then if we remember our test for a perfect square trinomial, that is x that's being squared. That is 3 that's being squared. Okay. If you multiply those together, you get 3x. If you double that, so times 2, do we get this number? If so, this is a perfect square trinomial. And perfect square trinomials factor into one binomial squared. Okay, because remember this was our a, this is our b, and this is a plus b squared equals 5. I don't have to have this one equal to 0 like I do for zero product property. So if I can write it like this, the rest of it's pretty simple in the fact that I'm going to square root both sides. X plus 3 equals, we have to add a plus or minus, and then you can't break down the square root of 5, so you just leave it, the square root of 5. And I want x by itself, so I'm going to subtract 3, negative 3 plus or minus the square root of 5. Okay, so if you have a perfect square trinomial, because that is what this had to be. This was a perfect square trinomial to be able to factor into this. If you have a perfect square trinomial, this works out really nicely. But is every trinomial a perfect square trinomial? No. So what we are going to do is a process called completing the square, and this makes a trinomial into a perfect square trinomial, because if it is, I can write it as one binomial squared equals something and then square root both sides. Okay, so in order to complete the square, first of all, a must be 1. So if you're looking at ax squared plus bx plus c, a has to be equal to 1, and if it's not, we're going to divide everything by a, and that will then make a equal to 1. So your steps to completing the square, okay, keeping in mind our ax squared plus bx plus c, we're going to take half of b, so half of our middle number, and we're going to square it. And then we're going to add it to both sides, and that step right there is called completing the square. So what you've done then is you've made a perfect square trinomial, and then after that we're going to factor the left-hand side. LHS is the left-hand side, and then use square root property to solve. And by the way, it mentioned that we have to be in this form. Notice there's no C. So to be in this form, to begin with, we're going to move C to the other side. Alright, so I know that's a lot to take in. This is lots of steps here. So let's see what we can come up with by looking at an example. Okay, and before we dive into actually solving, can we just find C? And this is the making a perfect square trinomial. So this was your steps. You're going to take half of B, which half of negative 12 is negative 6. Okay, and then you're going to square it. And anytime you square anything, your answer is always going to become positive, and so negative 6 squared is a positive 36. So it's half of B squared is what you're looking at. So if we do this again, B is this 8. So if I take half of 8, I get 4. 4 squared is 16. And so that becomes a perfect square trinomial that's going to factor into r plus 4 squared. So check that out and make sure that you understand how I factored that. Okay, so the first thing you should look at is this a perfect square trinomial? Well, there's no way it is because 5 is not a perfect squared number. So we want to get rid of the 5 first. So step number 1, get rid of 5. And I want you to leave a gap where the 5 used to be. Okay. So step number 1, move C. Step number 2, this is your completing the square. And this is where you're going to take half of B. So half of negative 18 is negative 9, and you're going to square it. So negative 9 squared is a positive 81, and you are adding it to both sides. That is the completing the squared step. Step number 3, factor and use your square root property. So if the left-hand side is now a perfect square trinomial, it has to factor into something squared. It's going to be x minus 9, because negative 9 times negative 9 is 81, and then you get your negative 18. Alright, so on the other side, we're just going to clean that up. And we get 64. Okay, so square root property says we're going to square root both sides. X minus 9 equals plus or minus, don't forget that part, 8. Solve for x, we're going to add 9. So x is going to be 9 plus or minus 8, and then we're going to do both those. So 9 plus 8 on the top there is 17. 9 minus 8 is 1, and those are your two answers. So let's look at that one more time. Okay, so first of all, you should check, because occasionally you might start with a perfect square trinomial. And I don't, because it's not even a trinomial. So I'm going to go ahead, though, and rewrite it and leave that gap. So step number 1 is already done for you. That C is already on the other side. So step number 2 was to complete the square. So we're going to take half of B, which is going to be negative 4, and you're going to square it. So negative 4 squared is a positive 16. We're going to add it to both sides. That is the completing the square. You just made a perfect square trinomial. Then I'm going to factor it. So it's going to factor into something squared. So this is going to be x minus 4 squared equals 20. Square root both sides. X minus 4 equals plus or minus. Well, does the square root of 20 break down? And this is where you need to remember we talked about breaking down radicals. I could write this as 4 times 5, which is the square root of 4 times the square root of 5, which is 2 square root of 5. Make sure that one of your numbers is a perfect squared number. So this becomes 2 square root of 5, and then I'm going to add 4 to both sides and get 4 plus or minus 2 square root of 5. You can't add those together because you have a non-radical with a radical. You are done. Okay, so take some time, make sure you can complete the square, and if you have questions, let me know. If not, I will see you in class. Have a great day.